we are really psyched to have this gentleman here. He is with the Institute for the Future. We spent about an hour before this talk just talking about the world. He has an incredible background, an incredible amount of knowledge in technology, and he is someone that you just want to sit and spend hours with. So we're fortunate to have him. We're thankful that you're here. So why don't we just start out with a quick introduction of you. From your bio, you've been at Intel Labs, you've been with Netscape, Times Mirror, Apple, you've done stuff for Clinton Gore. Tell us about what you're doing right now at the Institute for the Future, and what is the Institute for the Future?
Great. Well, thank you. I'm just delighted to be here. I think this is the third time I've been here, but it's been over many, many years. The Institute for the Future is a 42-year-old not-for-profit laboratory that was founded by 3 scientists from the Rand Corporation who wanted to do kind of non-classified work. So our mission is to help our clients, which are mainly large enterprises, think systematically about the future. We do not predict the future. If you want predictions about the future, you can go buy reports from Gartner Group, and they can tell you how many units it's going to ship in 2017. We don't go there. And we're very careful not to predict the future. But what we do is we help our clients construct credible, vivid understandings of what the future will be like. And we follow a methodology we call foresight to insight to action. So we create visions or stories about the future that are vivid and credible. And then the insight is contextual. So people bring their own personal knowledge and experience to kind of interpreting the results. And then they will then take their own action plans. Mm-hmm. So we work with large organizations, as I mentioned. I work for Intel Company, Toyota, Nissan, Nokia, Microsoft. I've given talks at Google and Apple over the last couple of years. I am the principal technologist in the Institute for the Future, so I lay out the technology kind of forecasts of the future. My colleagues who are social scientists will then tell the human stories of the future. Sometimes they'll come up with a human story of the future, and then I'll come back and fill in how the technologies are going to support those kind of behaviors.
So let's dive right into some of those vivid stories that you tell about technology. Mm-hmm. Let's start with maybe the first couple that you think are going to be interesting for companies to be paying attention to.
Well, as I mentioned earlier, I look at the foundations of technical change, and I'm very interested in what Hal Varian calls combinatorial innovation. Hal Varian, as you know, is the economist from UC Berkeley, now is the chief economist over at Google, and he talks about the present condition of having many, many disruptive forces at play. So I've created an inventory of what I think the disruptive technical elements are, technology elements, and I'm looking at how they're combined. So my taxonomy of technologies is around platform technologies, the network, the cloud, mobile and embedded devices, and then I break out the categories of utility in computing workloads. And then the final category is, in fact, the user experience, which is a combinatorial experience, which draws elements from many, many categories.
So just for the audience's sake, let's talk about combinatorial innovation for a second.
Sure.
You had a great description about how the heterogeneous nature of the Silicon Valley sort of allows this to happen. So tell us about combinatorial innovation.
Well, I can see about 50 discrete technologies, any one of which is going to cause great disruption. But what happens is that these technologies are combined in novel ways to create further disruptions. So we can't really just think about the future as just the future of cloud computing or the future of multi-core chips or the future of image processing. It's how these things are going to be combined in different ways, and they're going to be combined to support combinations of human behaviors and human activities. So there's a mapping of almost like 2 graph networks, a technical graph and a social or behavioral graph. And we're ideally skilled in the Silicon Valley at creating innovations on these combinations. You know, if you think about it, we've had many, many boom and bust cycles here in the Silicon Valley, and they're not like just simple oscillations. Each one of the booms is followed by another one that builds on the previous boom. So going all the way back, we had the semiconductor boom with Fairchild, Intel, and that whole gang. And then there was client-server computing, personal computing, multimedia computing, online services, web services, .com services, e-commerce, social networks, Web 2.0, big data, biocomputing. And at the kind of peak of each one of these booms, there's a new talent pool comes to the Valley from all over the world, people coming here, and it's accumulative. And so we're richly networked here in Silicon Valley, so people from many, many domains and disciplines get together in our normal lives here and create these combinatorial innovations. So I'm just trying to understand this schematically on how these things fit together and cause disruptions.
So you had a fascinating thing about cloud.
Yeah.
You mentioned cloud a couple times already, and most folks are kind of think of it conventionally right now. So what's the conventional view, and then what's your view of cloud?
Well, the conventional view, and I don't need to tell anybody in the room, the conventional view is that, gosh, enterprise managers can trade capital expenses for fee for services. That's, it's an accounting shift and it's an operational change. But that's really a pedestrian interpretation of cloud computing. I look at the cloud as the emergence of the global supercomputer. During the first 20-some years of the internet, we developed a web of knowledge. Now we're developing a cloud of computational resources. So what this means is that any application or service that we can imagine can now be enhanced and amplified with the power of the scalable supercomputing resources. And this hasn't been possible until now. Well, for technical reasons, the computing resources weren't well organized, but there's a cognitive problem. Human beings don't naturally think of things in concurrent multi-threaded processes. Computer science is really serial instructions, serial code, one instruction then another. But a supercomputer by definition does everything concurrently and multi-threaded in parallel. But our brains are not naturally inclined to factor problems into parallel sets. But now we've seen the development of Google's Big Table, MapReduce, and then finally we're seeing all kinds of middleware guys really kind of jumping on Hadoop, so that Hadoop can now factor big problems to run and manage all the concurrent parallel process. So we're seeing this now explosion here in the Silicon Valley, and people are running around talking about big data. But for me, I'm certainly interested in data and big data, but for me it's all about supercomputing and big computing. And so I kind of view the so-called big data explosion through that lens.
And on the note of data, you also have coined the term of, looking at the term of liquid data.
Yeah, I didn't coin it. I heard it from some guys in the National Cancer Institute.
So what is liquid data then?
Well, everybody in the room knows that data is isolated in many, many kind of unconnected repositories. And a lot of the data that's supposedly on the web really isn't on the web. It's just sitting on a server someplace, and you go to a website, and you've got to get into the query language to find your data and then bring it up and do something. So you can't do what I call blended analytics, and we need to do blended analytics to do transdisciplinary problem solving. I mean, supply chain coordination is a transdisciplinary problem. And the environmental science is by definition a meta-science. Ecology is meteorology, hydrology, botany, zoology, human sciences. And so to build an environmental model, you need to be able to pull the data from multiple data sets and create a coherent model. So you need liquid data, data that can flow effectively from one context or one domain to another. But in order to really create good liquid data, you need to know the provenance of the data, the validity of the data. You've got to have metadata about the data. What is it? All of those are really kind of prerequisites to the flow of good liquid data for blended analytics.
And you're also doing some work around the context of data as well. So talk about that a little bit too.
Well, context it's the economic foundation of the internet. I mean, everybody makes money on the internet by analyzing the user's experience on a page. and then they value the ads based on the user experience. That's contextual processing. We're approaching an age where our systems will know our itinerary, our agenda, our profiles, our preferences, our biases, our history. And so our systems should ideally be able to do things proactively on our behalf. And then wherever we're going, everything is queued up for us. All the documents, all the information. One of the best examples that you can imagine is like a physician who's making his rounds, and on his tablet, it pulls up all the brand new drug interaction information, the information about comorbid symptoms, the information about the latest test information, all in a blended, coherent way. But as individuals, we need to blend our data too. I mean, we've all got, what, 60 or 70 apps on our mobile phones? One app for fitness, another app for our diet, another app for our sleep, quantified selves. And to do the kind of blended analytics we do naturally and organically, we need to take the data from these different app repositories and pull them together. Before we had mobile devices and computers, all of our personal decisions were blended analytics in our heads. Now we've externalized everything. We're fragmenting our digital experiences. So we've got to begin to pull that back together so we can do contextual processing on our personal ecosystems, on information about places and activities, and information about the people and situations that we are interacting with.
And to display that information in a meaningful way, perhaps even in augmented reality.
Sure.
Right?
Sure.
And you mentioned an interesting exercise that you do right now. Can you tell us about what you do?
Well, I'm a huge fan of spatial information and augmented reality. We were doing augmented reality research at Apple Advanced Technology Lab back in the 80s. I've been on this for a long, long time. So for many years, I've walked around the world and I imagine I could see the invisible information associated with everything. Everything about the ornament on that building. I imagine I can look at a wall and I can see the electrical conduits behind the sheetrock. I look at a street corner and I imagine I can see, is this a dangerous intersection? I look at people and I imagine I can see their social network connections. I imagine I can see probabilities. So this is just as I say, a thought exercise to help me think about what is going to happen sometime after about 2020. Because right now we've got these, first generation augmented reality apps. We hold our Android or iPhone up and we can see a little data out there. But the data is kind of wobbling around because geopositioning is only within about 10 or 20 meters. So you can't fix the data to an object right now. So there are technologies that are going to allow us to align the data and the objects. There's also new technologies that will allow us to position our focal plane. There are markup languages emerging for focal planes. And there are many, many people now creating data sets that can be blended effectively for augmented reality.
And in the context of AR and capturing that information, you mentioned that right now our view of AR tends to be more of a top-down view. So it's this sort of satellite view of the world, right? What other data sets do you think are going to be important for people to be gathering and thinking about as we move into this more real AR world?
Well, I mean, so far, all of the spatial information that we've accumulated as humans has been formatted into maps, which are basically a top-down aerial view of data. And so for many, many years, I mean, all the way back, I was talking to Carl Anderson about this, all the way back in our days at Apple, we were talking about cinematic views of spatial data. So it's the idea of tipping the map plane up so you can see the geodata in the world. And so right now there are 3 or 4 kind of data sets. There's map data, which was originally designed to be rendered flat. There's geocoded web data and social data, your tweets, geocoded tweets or Facebook posts or something. And then there's sensor data, which is sort of floating in the air. It's not really fixed very well. And then there could be computed data, which is computed probabilities about things in space. But all of that has been designed to be rendered in a non-augmented view. So we've got to think more about oh, there's many, many user interaction challenges. You know, if you're wearing a pair of Google glasses or contact lenses, it's going to be pretty annoying if graphic blobs like popping up in your face and text. And so we really need to work hard on the user experience so this stuff is not annoying, so it's really productive. And I'm glad to see Google is working on it.
And you were mentioning also some thoughts around visualization of information, visual complexity being one of the sites, and there's a lot of places that are starting to really sort of synthesize this information in a useful way, but my contention was that it's still not particularly that useful. So what should an entrepreneur be thinking about? What are some problems that could be solved that would make this information more useful and more synthesizable for the user?
Well, I mean, you've got to look at the whole technology stack. I mean, you've got to make data useful, and that means good metadata, and it's got to be valid data. And then you've got to carefully construct your models. The models and the simulations have got to be credible. So there's a lot of work to do there. And then taking very, very complex data sets and visualize them in a way so they support you know, your casual ambient decisions. You don't want to have to stop what you're doing, pull up a big complicated app and like do stuff with the model. You want it just to be there all the time. So I think what we really need to do is understand that right now we've kind of made knowledge, there's a layer of knowledge everywhere now. We've got the web. We can just, within a Google search, we can find anything instantly. There's another layer, which is the computational layer, which is applied analytics. And there's another layer on top of that, which is the user experience of analytic data. So you need to get your designers and your big data scientists together. I mean, there's just, the world is full of opportunities of creating visualizations and models of enterprise activities, as personal activities, recreational activities, all of that.
So tell us about some other interesting vivid stories or foundational technologies that you're talking about with your clients.
Well, it varies from client to client. You know, one of the things I've been working on, as I mentioned, I work a lot in health and biological informatics. So I spent time last year with the Institute of Medicine and the U.S. Department of Health and Human Services and the Office of the National Coordinator, and we've been looking a lot at health information ecosystems because human health is just one of those meta sciences that just begs for blended data. And so I've been looking a lot at decision support for physicians. Gosh, 20 years ago I did some ethnography with physicians, and we found that physicians need research about 11 times a day at a minimum, and they're not doing it. You know, the good ones come in a little early and do a little bit of web browsing before the patients come in, or they flip through their journals. But a lot of physicians just can't keep up, so they don't.
Because it doesn't build confidence in the exam room to be flipping through the guide.
And the problem is now patients are coming to the doctor's office with a stack of Google search printouts, and there is absolutely no way to know to sort through the folklore and the credible information that people bring in. You know, there's as much misinformation on the internet as there is good information about human health. So I'm doing a lot trying to understand how people's personal information ecosystems can be effectively blended with clinical information ecosystems. And I don't know how many people here were there or knew about the big event in Washington 2 weeks ago, the Open Health Data Conference called the Datapalooza. It was a stunning event. It was like one of those events, if you were there, you say, wow, it's not going to be the same after this.
So 150 startups were there.
150 startups. There were.
What were you saying?
Oh, well, there are all kinds of people who are taking large data sets and building consumer apps that can do, you know, predict things about your health. There are people who are building clinical apps on large data. The U.S. government announced a rollout of 283 data sets that are linked with RDF, with semantic web languages. Aetna had one of the most interesting examples. Aetna came up with something called CarePass. And so they're blending personal patient records with clinical research and other data sets, and then they're publishing APIs. So, and they're inviting app developers to build apps for individuals and clinical apps based on the data sets. That's pretty exciting. And there were probably about 3 or 4 other big companies doing similar things, and then dozens of startups. There's a company here in Sunnyvale, Medgle, M-E-D-G-L-E, that's got his own analytic engine, and he's offering APIs for that. He's doing field testing in India. So there were just tons of startups that are doing all kinds of predictive analytics on health data sets.
Mm-hmm. So I think we're going to probably get to Q&A pretty soon, since we're only a half hour. And how much time do we have left? How are we doing on time? We're doing probably 10 minutes at the most. 10 minutes left? Yep. Okay. So we're at 10 minutes left. I had a couple other questions I was going to ask Mike, but I also wanted to open up to the audience for any questions. Yeah, go ahead.
So neuromorphic chips, number one, is that on your radar? And if so, do they figure very much into your, not predictions, but into your storytelling?
You know, there's some guys that hang around the Institute for the Future who are looking at neurosciences and neurocomputing. And we had a specialist in neural connectivity and neurocommunications come and talk to us yesterday. And yeah, that figures into the future, but I'm much more interested in the idea of cognitive models, not just neurological models. I mean, we're learning a lot about the signal paths, but it's like looking at a circuit board and seeing lights light up and having no idea what the data or the computing processes are. And I'm more of a software and data guy, and I care a little bit less about electronics than I probably should. And the neuro stuff is also a little bit tangential to my focus. But I do try and understand what people are thinking about theories of mind, you know, Marvin Minsky's Society of Mind, all of that kind of stuff. I think that's really important. So I'm a big skeptic of the singularity, the idea of uploading human consciousness. We don't even know what human consciousness is, let alone how to upload it, but that's another topic. Go ahead.
If you could say something about blending and how you differentiate that from synthesizing.
Oh, you know, it's just semantics. I mean, yeah, synthesizing, it seems to include a value add. You know, it's like a careful construction of a structure. Blending is just like pouring stuff together and then see what you can do with it. So it's a qualitative difference. It's not any kind of rigorous difference at all. You probably could use both words interchangeably. Yeah, I think we need to bring in a lot of data from a lot of places and good data. You know, we really need to work on the quality of data and you know, I mean, as a lot of people know, there's kind of 2 ways to think about data mining. One is by constructing really good queries. The other is just like get the data and let the patterns speak for themselves. So I mean, blending data might speak a little bit more towards organic conclusions from the data, and synthesizing might be like query-based constructs. I don't know, I'm just winging it.
Jenny.
I'm really interested in the retail space. So 10 years ago, you know, everybody was shopping in brick and mortar shops, and then e-commerce came along. What do you think 10 years from now, what kind of technology is really going to disrupt the retail space?
Well, you know, we had some great conversations before the meeting on that. Some of our biggest clients are worried about that. We work with Tesco, we work with Walmart, we work with Procter & Gamble, and we work with Dalian. Is that a Chinese retailer? I don't work with them. We work with one of the biggest retail stores in China as well. So I mean, I think augmented reality is going to play a big part. I think the idea of contextual information as you're moving through a retail space to use the actual physical products as keys to a much richer digital experience. I mean, retailers are going to have to do some things like that to empower people to do more logical conclusions. We see some tension. You know, some retailers are afraid of putting Wi-Fi in the store because they're losing customers. People come in and window shop and then order it off of eBay or Amazon or someplace else. A lot of our work is focused in some of those areas.
So you talked about quality of information
Yeah.
and drawing conclusions from that information.
Yeah.
So there's two things. One is, I mean, now we're seeing just loads of information.
Right.
So that goes to the quality part of it. The second one is, like you said, the augmented reality where you look around and you see all these things seem like such a distraction and everything. So what do you see in terms of culling that information to make sure there's quality there and the information that is getting presented to you is of value?
They're really two complete processes.
Yeah.
The quality information is a pre-process. You don't want to see anything that is not valid. And then the second process is contextual processing. So your system's got to know enough about what you're doing at any given time to present not everything. We'll just die if we're like flooded with. And there's these videos on the internet. You can type in augmented reality. There's a guy named Kichi Matsuda. It's got a really cool video. If you haven't seen it, Augmented City. It's a good YouTube watch. But he forecasts a world that's like filled with brand identification. So your personal information ecology will become the template, the filter for mining the world of ambient information. And so your system is going to turn things off for you as well as present things. And so this, by the way, this whole notion of contextual processing is an incredible dilemma because we're torn with the fact is that now we've disclosed everything and our lives are transparent. And you know, I saw the story about Axiom having data on 500 million people in the world with 1,500 data points per person. So the people in the cloud know about us and they're doing the contextual processing, but the price is that we've given up rights to our privacy. So it's a tension, but I ultimately will find some kind of balance. But this personal construct, this personal information ecology is going to be the filter that's going to be doing the mining to give you just what you need in augmented reality or in anything else that you do. It's that contextual process.
Michelle, you have something.
So you were talking earlier about combinatorial technology.
Yeah.
What's the most unexpected combination of things that you've seen recently where you say like, oh my God, I can't believe they're putting A plus B?
You know, I'm not surprised much anymore, you know, because I think about this stuff about 10 years ahead of time, and I've been doing it for about 30 years. So I can tell you some things that surprised me, but I mean, I was surprised by the iPhone. It was just so well done and so perfect and so transformational that you know, I mean, that was a real set of combinations of, you know, hardware engineering, software engineering, user experience engineering, service design, data design, everything. So that, I mean, to me, that was probably the most brilliant example of a combinatorial experience that I can cite right now. But there are many, many others. Everything can be factored into the combinations of elements. It's recursive. There's hardly anything is a unitary trend.
You're a lover of science fiction.
Yeah.
What's something that from science fiction that you wish could come true, just for you?
So, well, I guess I really am hungry for augmented reality, you know. So, you know, I read Werner Vinge's Rainbow's End, which is really a pretty good AR story, or Charlie Stross, some of his stories. No, I'm pretty satisfied, basically. I don't crave much. You know, I read a story a few years ago about somebody had a briefcase full of sand, and it was like, you know, smart nano gray goo or something, and you could make anything out of it. I guess that would be sort of cool.
Nano goo.
Yeah.
Okay. Just a couple last questions. I am really curious about the cognitive toolkit that we might be able to learn from you, because you essentially synthesize huge amounts of information from multiple sources, in-person interactions, RSS feeds. So how can we as a group become better at thinking about thinking and thinking about the future?
Well, there's a few things that I do almost rigorously. Is read good science fiction, for sure. I mean, no kidding. I mean, read Bruce Sterling, read Rudy Rucker, Werner Vinge. William Gibson's not so far out anymore, but read good science fiction always makes a difference. Charles Stross, for sure, but you got to read the right Charles Stross. Don't read the wrong ones, or you'll be sorely disappointed. That's one. The other is I read omnivorously, but I read over my head. I am not afraid to take the toughest technical material and I read it whether I understand it or not, and it sticks. And then when I read something else, I can make connections, and I've been doing it for 30 years. And after a while, you hear something that other people would think is just kind of inconsequential. But for me, it's like catalytic connection. So I've built like a giant graph network of knowledge in my head, a holographic model. So those are two of the best things I can recommend. Read over your head and read imaginatively. And network like crazy. I mean, you know, we have just spectacular networks in the Silicon Valley. Yeah. So I network with my friends in AI and media and data mining and hardware and software. And
all right, well, thank you very much. I think we're done, or can we take a couple other extra questions? Or?
I have a question.
All right, Rod has a question. So one more.
Hiroshi keeps ignoring me, and I think he's pointing at me, he's pointing behind me.
All right, and we're done. Thank you.
So, one of the reasons we asked you to come was that the VLAB community is actually really good about thinking on the next 3-year, 4-year, 5-year space. Mm-hmm. And we've got a good track record, a very successful track record at hitting that. Mm-hmm. But for me to think of what could be in 10 years, what could be in 20 years, I kind of stand back and just say, can't do it. So do you have a methodology that actually does say, okay, here's how you think about 10 years out, here's how you think about 20 years out?
Mm-hmm. First off, we look for what we call signals, and everybody here does it too. I mean, you cruise the web and you look for something cool. But for us, we look for things that are specifically credible indicators of what the future will be like. So we look for lots of those. And I collect those forecasts. And so last year, I interviewed leading computer scientists in Silicon Valley, in Beijing and Bangalore, and I did a trip down to Sao Paulo, and I did some work in Munich as well. And we collect expert opinions. So we collected about 700 forecasts. We distilled those 700 forecasts. Then it was about a 10-year time frame. You know, what do the bright guys think? You know, the interesting thing about an expert opinion is an expert can give you a very crisp forecast within his or her field of expertise. But if you get two experts together, it's where their forecasts intersect. You come up with an insight that neither one would understand independently. So we took these forecasts, distilled them down to about 200 distinct forecasts, and then I created a controlled vocabulary of tags, not just random, you know, Twitter or hashtags. And then I created a graph network visualization. So I've got them by geography, by consumer clusters, by enterprise clusters, by about 10 technology categories, platform categories, and user experience categories. So you can click, say, okay, China, data mining, and health. There's the graph of expert forecasts that seem to be involved with those things. Or I could pick a forecast and see where it has impact. And so that's one of the methods. So a lot of what we do is actually aggregating expert opinion, and that really, really works. But we do it systematically and methodically.
All right, one last one that he's been so eager. All right, yes.
That's two questions, and okay, the first question about augmented reality. First off, what's the killer app of the web? No, there's many killer apps of the web. There's thousands, there's millions of killer apps of the web. Augmented reality is just the web tilted up in the real world. It's the web escaping from the page or the screen into the real world. So every aspect of human life is going to be changed by augmented reality. Real-time sensor information, facilities management. You can see the facilities. You can walk up to a machine and the machine will tutor you how to operate the machine or repair it. Just-in-time learning. I think one of the breakout apps in augmented reality is going to be games. I don't think we're there yet, because I think that holding up your iPhone or your Android phone is awkward. And I think that the Google Glasses is a great research project, but it's not going to be useful in the next 5 years. Probably around 2020, we're going to have pretty good glasses. By 2025, we'll have contact lenses. And after that, the children will never know a world that isn't ornamented with rich data. So information overload, it's the same answer to his question, is that your personal information ecology will become the template for filtering just the information you need and the information you don't need. So we've got to get really good at contextual processing. It's a big opportunity, but it's really a problem because everybody who makes apps is making a little walled garden. And my data is my data, and I'm not going to share it with you unless you pay me for the API, and it's crazy. So there's going to be some breakthroughs. There are even people thinking about operating systems on mobile devices that just scrape everything, capture all your keystrokes and capture your screens and give you a complete repository of all your data that then you can do the blended analytics or synthesis, if you want, of your own data. So we've got some disruptions to go through, 3 or 4 disruptions before we really solve that overload problem.
All right, thank you very, very much.
Thank you.